8th grade. So section P1, algebraic expression, mathematical models, and then real numbers. Okay, the big thing we're going to hit is going to be set notation. Whenever we talk about a set, and with all of these, you don't have to write down everything. You write down what you think you need, but you're not really going to be tested on your definitions. Okay? If you need to write that down as far as to know what you're dealing with, that's fine, but you don't have to write down every single definition. If you just want to go with the examples, that's fine. It's completely up to you with what you write down as far as your notes are concerned. A set is really just a collection of objects whose contents can be clearly determined. Okay? So in this case, 1, 2, 3, 4, 5, so on and so forth is just the set of counting numbers. Okay? The ... at the end just means that it's going to continue to move forward. It's just going to keep going on and on. Okay? Basically to positive infinity in this case. So whenever we have a set, you have the different parts that are in the set. Those are what's called the elements. That is the 1, the 2, the 3, the 4, the 5, so on and so forth, and everything else after. Okay? Your elements are just the parts in your set, is all it is. Okay? So whenever we talk about the elements, we're just talking about the pieces of the whole thing. Okay? If you think about a set, Laws' second hour pre-calc class, you all are elements of that set, right? You all are the butts in the seat, basically, that make up this class, is how you've got to basically think about it. Okay, you're an element of this class. Whenever we talk about roster method, that just means it's going to use the braces. Okay, it just means that we're indicating a set. So like 1, 2, 3, 4, and 5. Okay, so basically we cut down the whole set of all the positive counting numbers, and we just took the first 5. Okay, the braces just mean, hey, this is a set. My elements in this case are 1, 2, 3, 4, and 5. One way of writing a set is roster method. The second one is then what's called builder notation. Okay? It's basically like writing a description of what we're talking about. Okay? So instead of listing 1, 2, 3, 4, and 5, we just say that X, or any number, any element in this set, is a counting number less than 6. So 1, 2, 3, 4, and 5. Okay? It's just a different way of writing it. Okay? It's basically just describing the set instead of telling every single element in it. You'll want to use builder notation whenever your set is really, really large. Okay? Whenever your set's really big and you have to describe it, you don't want to write out if there's 100 different elements to it. You want to be able to shorten that down maybe just by writing a description for it. Okay? If there is a specific one. You know, like if we had even numbers from all the way up to 100, you don't want to write out 2, 4, 6, 8, 10, all the way up to 100. You would just put the bracket, or the parenthesis, the bracket rather, or the braces, and then have X, and then the bar, and say that X is an even counting number up to 100. You know, something like that. To where you're not having to write out 50 different values. Okay? So in some cases, builder notation is better than roster method. Now, the 3 different types whenever we combine sets. Okay? An intersection is whenever we have is a new set that basically combines one or usually 2 different sets. So like in this case, if we say A is an intersection of B, for it to be an intersection, then it has to fall in both set A and set B. So kind of going back to whenever we talked about you all being an element of Laws' second hour pre-calculus class. And I'm going to use marching band because I know I have students that are in marching band first hour. Okay? If marching band is, if I talk about first hour marching band being another set, what's the intersection? What are the people that fall under both categories? So how many people are in marching band first hour and my pre-calc class second hour? Okay, so U5 would be the intersection. Or if I said athletic strength training, okay, you know, or if I said Griffiths' first hour or Maury's sixth hour, okay, there may be people that are in both classes. You have to be in both to be in the intersection. Does that make sense? Whereas the opposite of that is the union. The union is formed where it can be in either set. So if I use Lawes' second hour pre-calc class and I use marching band first hour, it's any person that's in one of those classes would make up that union. Okay? What happened? The intersection was really small, right? There were 5 of you, I think, that were in both marching band first hour and my second hour class. Whereas if we do the union of those two same classes, it's going to be all 27, 28 of you that are in here, plus the 100 and whatever students that are in marching band first hour. Okay? Our set got really big, okay, because it's one or the other. Even the 5 people that overlap are still in that union. Okay? They don't get excluded. They're always going to be in either the intersection or the union. If it's in the intersection, it's going to be in the union. Now, the flip side of that is then what's called the empty set or the null set. Usually I'll call it the empty set. That's basically the set if we have 2 sets where it doesn't apply to anyone. So like if I talk about the set of my second hour pre-calc class and I talk about Maury's second hour social studies class, whatever he's in. Is there anybody that's going to be in both, that's going to be in the intersection of that? No, why not? Because you can only be in one class at a time, right? Okay, so that would be an empty set. There wouldn't be any overlap there. There's people that are in my second hour class. There's people that are in his second hour class. There's no overlap there. So then on the first 4 for the examples, it says find the intersection of, you have a set, the first set of 7, 8, 9, 10, and 11 with the intersection of the set with 6, 8, 10, and 12. So what's my overlap on 1? Do I have an overlap? Is there an overlap? Is there one element that's in the first set that's also in the second one? Okay, I got head shaking. What is it? Or what are they? 8 and 10? So 8, 10, and then close the brace. 1, 3 got repeated, 7 got repeated. So my intersection here is 3 and 7. Now, whenever we talk about the union, so remember, the intersection, those sets are going to be smaller. It's basically, it's going to get smaller. It could be every single part, okay, of maybe one of them. But whenever we talk about the union, those are basically going to combine. It's one or the other. Okay, whenever you write the set out, go from least to greatest. Okay, it just makes things a lot easier. So then you kind of know. So like the union of 3 would go 6, 7, 8, 9, 10, 11, and 12. Now on this one, could you write it in builder notation, or could you write this with words? Okay, yeah? What would you, if you would, how would you say it? Or what would you say?
Such that whole numbers between 6 and 12.
Including 6 and 12. Okay? Because between is not going to include those. Okay? So maybe if you said like counting, like I think I wrote it first hour, X such that counting numbers between 5 and 13, because it hit those, because between it didn't include those values. Yeah.
Why is like the little U thing, like
because we're going to use like this one here for the union. Okay, it's like the U with the union. The intersection is really just we're just going to go the opposite of it. That's just the notation that we use with it. Okay. Okay. You could even write it to be honest, like I would be okay if you wrote it with X such that, and we went 6 is less than or equal to X less than or equal to 12. That even works. Okay, that's even simpler than even writing it in words. Okay, it includes 6, it includes 12. And we would probably need to say something like where it's the counting numbers. Okay, because there it's going to hit every value between. But so what's my union of 4? Basically from where to where? 3 to 9, right? So we can just go 3, 4, 5. X such that from basically counting numbers from 3 to 9. Something along those terms or along those lines. Now, this here is all stuff that you've seen before. We've talked about it. I know you talked about it in Algebra 2. You talked about it whenever you were in Algebra 1. Whenever we talk about the different types of numbers, all numbers are just sets. Okay? You have your smallest set of natural numbers, where it's all of those counting numbers that are positive. Okay? Whenever you learned how to count, whenever you were in kindergarten, preschool, whatever, you always started with 1. And you went 1, 2, 3, 4, 5, so on and so forth, until you got up to wherever you could go. The next set, the only other value that we add to a natural number, all we're doing is just building on one another. So the natural number is the smallest, then we go to whole, then integer, then rational, and then it splits off into irrational. Remember, a natural number is a counting number that's positive starting with 1. Whole number, all we're doing is just adding 0 to it. An integer is then going in the negative direction. It's the -1, the -2, and keep basically whatever positive counting number I have the opposite in the negative value as well. A rational number is just one of those numbers that can either repeat or terminate as far as the decimal is concerned. All rational numbers are integers, are whole numbers, and are natural numbers. All natural numbers go all the way down to rational. Okay? For it to be rational, it's going to have or house all of the integers, all of the whole numbers, and all the natural numbers. Irrational numbers are the numbers that do not terminate or do not repeat. Pi, any sort of square root, cube root, fourth root, whatever, that is not a perfect square, a perfect cube, a perfect fourth. Things like that. And then you have a real number, which is every number. So here you have a set. Okay, you have -7, -3/4, 0, 0.6 with it repeating, the square root of 5, pi, 7.3, the square root of 81, and 0. So as we go, since we go from natural all the way, if we go down and then back up, then it goes to whole, then it goes to integers, rational numbers, irrational, and real. Okay? Depending on how you want to go, I would either go to the smallest set and then work your way, or go to the biggest set and go from there. Okay? Like if we go from the biggest set, which is the real numbers, is there a number that I'm not going to put in the real number set? Is everything there real? Yeah. So if you want to work kind of backwards, or really from large and then break it down as you go, I would just really relist everything. I'd have -7, -3/4, 0.06 repeating, square root of 5, pi, 7.3, square root of 81, and 0. So you could start with your largest group, and you could go to real numbers in this case and write every single one out. You also could start at natural numbers and look at your set and say, okay, which one's a natural number? Okay, is -7 a natural number? Yes or no? No. And just kind of work your way down the list. Okay. Now, what's the only natural number we have in our set? Square root of 81, right? Okay. Now, what is the square root of 81? 9. Don't write it as 9. Okay. Write it as the square root of 81. That's the element that's in there. Even though it has a different value, okay, or it has a different name, you still want to write down what it shows. Okay. First day of school, I asked you if there's anything you want to be called, that's what we're going to call you. Okay. So I've got 3 Abigails, but all of you said, I want to be Abby. Okay. It's the same thing, right? But if it reads Abby, we're going to write it as Abby, even though the real name is Abigail. Okay? The more sophisticated name. Right? No? 0 is a whole number, but I also have to add have to keep the square root of 81 and the 0 that I have. Now, one thing that I should have done correctly, I should have wrote it from smallest to largest. Okay? I should have put 0 and then the square root of 81. And gone to there. Same way then with an integer, what am I going to add to the list? -7. There's nothing else that I'm going to add, so I would have -7, 0, square root of 81. Okay, and then take the integer list and I would build it up into my rational list, my rational set, and go from there. Same way with irrational. Whatever's not in rational is going to be in irrational.